Hi students, today we are going to discuss about a new topic. It's about dimensions of a physical quantity. We know physical quantities are classified into two. One is fundamental quantities and other one is derived quantities. And we know that all the derived quantities can be expressed in terms of some combinations of the seven fundamentals or base quantities, right? We know all the derived quantities can be expressed in terms of the fundamental quantities, and we know there are seven fundamental quantities. We call these fundamental quantities as seven dimensions of the world, which are denoted with square brackets. I will write the dimensions of the seven fundamental quantities. First, dimension of length. Dimension, we know length is a fundamental quantity, and dimension of length is represented by a square bracket, and we write L to denote the length. And what is the other fundamental quantity? Second one is mass. Mass is the second fundamental quantity, and its dimension is denoted by capital M, and it is written in square bracket. This represents the dimension of mass. Then another one is time. Time is the next fundamental quantity, and its dimension is capital T. Then dimension of electric current. Electric current is equal to, it is not I, it is square bracket A. Square bracket A represents dimension of electric current. Then other fundamental quantity is thermodynamic temperature. Thermodynamic temperature, its dimension. Can you guess the dimension of thermodynamic temperature? We have already used T for time, and thermodynamics temperatures dimension is square bracket K. K represents Kelvin. We know the standard SI unit of temperature is Kelvin, and square bracket K represents the dimension of thermodynamic temperature. Then the next quantity is luminous intensity. Luminous intensity, its dimension is CD. We know candela is the unit of luminous intensity, and square bracket CD represents dimension of luminous intensity. Then the last one is dimension of amount of substance. Amount of substance. Amount of substance, its dimension is equal to square bracket mole. So this is about the dimension of the seven fundamental quantities. Then we have derived quantities also. Then what about their dimension? What is their dimension? So let's discuss about the dimension of the other physical quantity. Okay. For that, let us take the example density. We know density is a derived quantity. And what is the equation for density? Density is equal to mass by volume. Mass by volume. So we think how we get the dimension of this derived quantity density. For that, we can write this equation as it is equal to mass divided by volume is length into breadth into height will give you volume. Therefore, dimension of density is equal to dimension of mass by dimension of length into dimension of breadth into dimension of height, and we know all these are lengths, so it is equal to dimension of length, dimension of, again we have three lengths here. So dimension of density is equal to dimension of mass. How we write dimension of mass? Dimension of mass is denoted by square bracket m divided by dimension of length is L, and again we have L, and we have L into L, which is equal to square bracket m divided by L raised to 3. L into L is L cube. So it is m divided by square bracket L cube. Dimension of m L raised to minus 3. And actually the usual pattern is that when we write the dimension of a quantity, we write m, L and T in that equation, that or the three terms will be included in that equation. So this can be written, but we don't have the dimension of T. So how can we write that? If we want to include that also, which is equal to m L raised to minus 3 T raised to 0. And if we check this equation, you can see that the dimension of density is equal to, what is the power of m here? It is equal to 1, and power of the fundamental quantity L is minus 3 and T, its power is 0. So we can say that if you check this equation, we understand that the dimension of density is 1 in mass, minus 3 in length and 0 in time. So how we define this dimension? Can you define dimension? Dimension of a physical quantity are the powers to which the fundamental quantities must be raised to represent that quantity completely. That is, M, L, T are our fundamental quantities. And when you check this equation, you can see that the power of mass in this equation is 1, and the power of L must be raised to minus 3. Then only it represents the dimension of density. So we can define the dimension of a physical quantity as they are powers to which the fundamental quantity must be raised to represent that quantity completely. Okay, this is about dimension of a physical quantity, and this is how we obtain the dimension of the derived quantities from the 7 fundamental quantities. And now let us take another example and let's see how to get the dimension of that physical quantity. Okay.